Good morning, fifth grade. This is Miss J. Today is Tuesday, April 14th, and we're going to be starting a brand new unit in math today. Now, before we get started, make sure that you have all your materials out in front of you. Now, for our brand new unit, Unit 5 in math, we're going to be learning about patterns. But our first concept today that we're going to be learning about is coordinate planes. Before we get into that, we're going to do some review from fourth grade on a few terms that we learned. Parallel. What does parallel mean? That's right. Two lines that are equidistant from each other and they go on forever without intersecting. Perpendicular. What does perpendicular mean? That's right. Two or more lines that cross and they form a right angle. So now that we did a little bit of review, now we can jump into our problem solving task. It's in two parts, so we're going to do A first and then B. So this picture shows an intersection in Stony Brook Village. The town wants to construct two new roads, Elm Street and King Street. Elm Street will intersect Lower Sheep Pasture Road, run parallel to Main Street, and be perpendicular to Stony Brook Road. Sketch Elm Street. So I want you to pause the video here, do your best to complete it, and then we'll come back together and discuss it. Welcome back. So this is where I decided to put Elm Street. Do you agree? You know what? I think I made a mistake. It runs parallel to Main Street, but it is not perpendicular to Stony Brook, and it's also not intersecting with Lower Sheep Pasture Road. Why is Elm Street in the right place now? Yep, because it is running parallel to Main Street, which means it is equidistant from Main Street and they're never going to intersect. Then it is perpendicular from Stony Brook because where it crosses, it creates a right angle. And it's also intersecting with Lower Sheep Pasture. You're going to do part B and come back once you've done it. Welcome back. So for part B, we had to make sure that King Street would be perpendicular to Main Street and then begin at the intersection of Upper Sheep Pasture Road and East Main Street. So we can see here that this is the intersection between the two roads. And in order to make King Street perpendicular to Main Street, meaning that they create a right angle, this is where you should have drawn King Street. So we did all of that work so that we could review what parallel and perpendicular means. Now I'm going to pull up a picture of something that we're going to be working with. This is a coordinate plane. I'm going to show you that it is actually made up of two separate number lines. We have the vertical number line that in this case goes from 0 to 20. Vertically, we call this the y-axis. Then we have the horizontal number line that goes from 0 to 20 horizontally, and we call that the x-axis. The y-axis and the x-axis meet at a special place called the origin. That's where they both equal 0. So the important things to remember here are that coordinate planes are made up of two number lines that intersect at a right angle. Vertically is our y-axis, horizontally it is our x-axis, and they meet at a special place called the origin where they both start at 0. Now let's play a game. I'm going to name something on the coordinate plane and you're going to point to it on the screen. Where is the origin? That's right. This is the origin. Where's the y-axis? Awesome. Here is where our y-axis is. Where is the x-axis? That's right. That is our horizontal number line. Awesome job. So now you're going to pause the video right here, and then you're going to begin your practice problems. Once you've completed them, you're going to come back to the video, and then we'll go over it together. See you soon. Welcome back. So let's talk about our practice problems. Question number 1. A landscaper is planting some marigolds in a row. The row is 2 yards long. The flowers must be spaced 1/3 yard apart so that they will have proper room to grow. The landscaper plants the first flower at 0. Place point on the number line to show where the landscaper should place the other flowers. How many marigolds will fit in this row? So we need to figure out where we're going to place these marigolds on the number line, knowing that they have to be 1/3 yard apart from one another. So let's look on our number line from 0 to 1. What do you notice? Yeah, I notice that this hole is divided into 18 pieces. If it's divided into 18 pieces and I'm trying to find 1/3 of that, I know that 1/3 of 18 is 6. So there will be a marigold placed every 6 spaces. So we have starting from 0, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and then so on and so forth. So this also can be written as 1/3 of 18, or 1/3 times 18 equals, or 1/3 multiplied by 18 equals 6. So 6 marigolds will fit in this entire row. Question number 2. Miss Warren started her hike at Badwater Basin, which is at sea level. She hiked up to Telescope Peak, which has an elevation of 24 meters. Represent her elevation change on a vertical number line. So this is Badwater Basin. We know that she hiked up to Telescope Peak and had an elevation of 24 meters. So this means that she started at 0 and hiked up. So let's create our vertical number line. So as you can see here, I drew my number line. Now this isn't ideal because ideally I would have graph paper and I would be able to draw it out to draw my number line. But in this case, I've drawn it. But in this case, this is how I was able to draw it. So you'll see that I have 0 at my origin to start. And I've created my hash marks up my number line all the way up to 24. Now, it's really important also on your paper, you should have these hash marks all labeled. So this would be 1, this would be 2, and so on and so forth. So this would be a representation of Miss Warren's elevation from Badwater Raisin to Telescope Peak. Question 3. Write true or false next to the following statements. If the statement is false, correct it to be true. On a horizontal number line, the numbers show the vertical distance from 0. That is false. On a horizontal number line, the numbers show the horizontal distance from 0. So this is false. On a vertical number line, the numbers show the vertical distance from 0. That is true. For example, here, this is our vertical number line, or the numbers show the vertical distance from 0. A vertical number line and a horizontal number line will be parallel. This is an example of what our horizontal number line would look like with our vertical number line. Is that parallel? Nope, we learned that it is perpendicular because they form a right angle. So that is false. The vertical number line is called the x-axis. That is false. The vertical number line is called the y-axis. The horizontal number line is called the x-axis. Yep, that is true. Good job. Today's math secret code is RAIN. R-A-I-N. RAIN. All lowercase letters. R-A-I-N. Number 4. Use the number lines to answer the questions. Plot t so that its distance from the origin is 10. So our number line starts from 0 and it ends at 12. Let's see if we can just count the hash marks to figure out the numbers in between. To figure out how the hash marks are labeled on the number line. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we know that this number line is counting by 1. And we're trying to figure out the distance from 0 to 10. So we want to plot t so that t is 10 away from the origin. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is where we would plot t. T's distance from the origin is 10. Plot m so that its distance is 11/4 from the origin. What is the distance from P to M? We can see that our number line is divided into fourths. So we see that our number line is divided into fourths. So first thing that we're going to do is plot M. We know that 11/4 turned into a mixed number is going to be 2 and 3/4. So we're going to plot 2 and 3/4 on our number line. There we go. That's M. So now we're going to figure out what is the distance from P to M. So if this is 2 and 3/4, we know here that P is plotted at 1 and 1/4. So we're going to subtract the 2. And our answer is going to be 1 and 2/4. Question number 5. Part A, label the x-axis, y-axis, and origin on the coordinate plane below. So today we learned that our vertical number line is our y-axis. Our horizontal number line is our x-axis. And our origin is where the x and y axis meet. Part B, label each hash mark on the number line so that each hash mark represents one whole. So I'll label this 1. That's one hash mark. 2. 3. And so on and so forth. And when I get to the last hash mark, that would be 24. And the same would be for the x-axis. Now, because I'm not able to write directly on it, it makes it a little bit more difficult, but hopefully we get the gist. If you have any questions about this, please reach out to your teachers and ask clarifying questions. Number 6, create a vertical number line to show the height of the following plants. So we're going to create a vertical number line, which we know is up and down. Now, when you're creating a vertical number line, it's absolutely important to make sure that you are labeling. So our first point is going to be 8/10 centimeters. That's our cactus. So here I did my best to showcase how we would create our horizontal number line. So you can see here that I've plotted all my hash marks from 0 to 10, right? And you want to make sure to label it. For example, we labeled it 0 starting at the origin, and then 1, 2, and you should have labeled it all the way up to 10. Now I've placed all of my plants on my number line. I have rose, succulent, cucumber, cactus, and tomato. And we're plotting that in order from 0 to 10. So here you see I started with my lowest which is 8/10 for cactus, and I labeled it cactus. Next would be cucumber, and we would label this cucumber. And then succulent, and we should have labeled that succulent also. Then we have tomato at 8.5 centimeters. And then lastly, we have rose. And you can see our last hash mark is 10, and 9.1 is right after 9. Question number 8. What is one similarity between the x-axis and the y-axis? They share the same origin. What is one difference between the x-axis and the y-axis? The x-axis is horizontal, the y-axis is vertical. Question number 9. Plot A so that its distance from the origin is 2. So I'm going to count from 0, 1, 2. This is where I plot 2, and I'm going to make sure that I label it A. Always remember to label your points. Plot R so that its distance from the origin is 5 halves. Have 1 half, 2 half, 3, 4, and 5. I'm going to plot that R. Awesome. Lastly, number 10. Label the boxes below with the correct hash marks. So if we count from 0, we'll notice a pattern. Let's try counting from 1. 1, 2, 3, 4, 5, 6, 7. Nope, I'm at 14, so we're definitely not counting by ones. Let's try twos. 2, 4, 6, 8, 10, 12, 14. Awesome, so this tells me that we're counting by 2. So I'm going to go ahead and label my empty boxes. 2, 4, 6. And start from 14 and count by twos. 16, 18, 20, 22, 24, 26, 28, 30. Now I'm going to count my x-axis. And if my x-axis is counting by twos, then most likely then my horizontal axis is also counting by twos. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. It would be 22. And then if I count it on, my last hash mark would be 36. So you're going to pause here, head over to Google Classrooms, and complete your math exit ticket. As always, if you have any questions, please reach out to your teachers and make sure that you're asking any questions where you need clarification.